Alright, so with as little information as there is out there, and even after I filmed the video of me setting up my own ring and pinion gear, I found that after I watched the video, it still doesn't make a whole lot of sense to most people. So we're going to start by describing it this way. So what you're going to do is you're going to first have to understand how they set up the measurement for a ring and pinion, or for the pinion anyway. And on the end of your pinion gear, there's going to be a number stamped. On mine, I think it was 2 inches, 825 thousandths. I do believe that was the number stamped on it. But that is the distance between the, excuse my drawing here, it's a little crude. Alright, this is your pinion gear in the housing. Between your pinion gear and the center line, I know I'm drawing this twice, but that'll make sense in a minute. The center line of your bearings. So this is this, if this is the center, then this line continued up would be your center line. So from this point here to the face of this here, you want what would be 2 inches, 825. Okay, that's the measurement you're looking for. Now, how to measure that, because you don't have anything free floating in there, what you're actually going to measure off of is the place on the caps where the bolts are. We'll get to that in a moment, but let's start off with how you set up the tool. Okay, first off, you take your tool, okay, or you take your bearing race, and you're going to measure basically anywhere from it. We'll go from this line to this line, and what I think I got 3.062 thousandths. That was it. Okay, that was that measurement. Now, if you took your carrier housing, alright, and you cut it right where the bearing caps are, basically did a cross section, it would look somewhat similar to this. I know that's horrible, but just bear with me. Okay, this is your this much is the part that your bearing sits into on the housing, and then over top of that you typically have a cap. Okay, and this is the part that the bolts go through. This is one bolt. It's another bolt. There's a hole through here, tapped hole here, tapped hole there. Okay, now you notice I deliberately drew it with this little gap in here. The only way that you can physically clamp something or hold it in place when it's round is one of two ways. Either number one, you make it perfectly in line with the cap, or two, you give it a little bit of a gap. Now, it won't be much of a gap. I honestly don't think you're going to see one over maybe a half a thousandth, but there will be a gap, and that gap is meant so that the bearing C can cinch down, okay, but not overly deflect the bearing housing, because if you do it too much, what the bearing will actually do is it'll go like this, and then it doesn't go around. So you want it to compress it but not deform it. That's what I meant to say. So what you have to do is you have to take your tool, okay, I'll draw another circle. What they want you to do in the instructions after you measured this is to take that tool with your dial indicator on it and move it around Like you're holding on this bearing. This cap's not on. Actually, let's just start over. You take your tool. You're going to take your tool. You're going to take your tool and lay it flat here with the dial indicator. So your tool's going to be like this, sticking off with your dial indicator in it. And you're going to, first off, you're going to zero it, you're going to zero it to the base of the tool, and then for like an inch, inch and a half, you might need an extension, you might not. And what you're looking for is what the depth here is. Now, whenever I did mine, I did it a little bit differently. Okay, I put the cap back on, and this is the way I recommend you do it. You put the cap back on, okay, and then measure this distance here with it torqued down. Whenever you torque it down, without this bearing in, this gap here is going to close. It's going to go away. But you're going to measure from here to here, and you're going to get a number. We'll call this number X, and then you take X divided by 2, and that'll give you this distance here. Okay, or excuse me, this half of this distance. Half of this distance. Alright? That is the way I would do it. Because I feel most of the time that your cap is going to be up off the bearing. But that's the best way I can think of doing it. Don't think of this as a tool to get an absolute. This tool gets you really get you closer than you will just by reading the paint. Okay? Now, a professional bearing tool, you will actually zero it out, and then you will clamp it with a little hockey puck in here. Okay? And then it doesn't matter. It doesn't matter. It's already on the center line. You get what I mean? That's why they're so expensive, because you have to machine each individual hockey puck. This one works off these little flat bars. Alright? So, once you have X divided by 2, which I didn't get a different measurement, because it's probably spot on, or it's small enough that, you know, if there is a difference, it's in the past this 0.062. I got 3.062 again. But if you did get a difference, what you would do is you would take the difference off of this center line. So for example, it should always be smaller. If, let's say, instead of 3.62, I got 3 inches. Alright, and then I divided both numbers in half, so this number here would be 1.531, and you divide this number in half, and you get 1.500. Okay, this 1.500 would be the number. I would have to add 31 thousandths to whatever measurement I got to bring me back to the actual bearing center line. Alright, because we're not worried about this. This is off a little bit because of the way it clamps down. Do you follow? So this measurement may not be exactly half. It might be a little smaller. I really doubt it's going to be this extreme. I honestly think 99.9995% of the time your bearing race dimension and this dimension are going to be pretty much exactly the same. If you get anything, I'd say over 3 thousandths, 2 thousandths, I would double check my measurements, because that seems to be too much, in my opinion, for a bearing. I do have a bit of machinist background, but just in case. But anyway, In my case, I both got the same number, so I have an inch 531, so I know that my bearing center line, excuse me, my bearing center line worked right off the edge of this thing. This is this plane for me, this plane right here. I can't believe I just traced that line. This plane was exactly the bearing center line. Okay. Remember, this is the bar, this is the tool. Okay. So what you'd want to do is, once you have your bearing center line figured out, is take whatever measurement you had. Like we had 2 inches 825 thousandths. You want to go to the next highest what do you call it, extension. So in my case, since 2 inches 825, I used a 3-inch extension. Okay, 0.300. Alright, then you're going to want to take, with your extension housing on, no, I'm trying to draw this so because you didn't really see it, but I clamp my checker thing, depth checker thingy, into a vise, because to do it with all 4 hands is kind of impossible. But on the bottom of it, you had, like, it was a nut like here, and then another kind of jammed it into the threaded part of the bar. Okay, and then your thing stuck down below here. Okay, what you want to do is, whenever you put that checker on, you're going to put it clean up to the top. You're going to set this actually down on. I like using the vise. It just gave me one less thing to hold on to. There's 2 needles that you have to worry about. There is the main needle, which you're going to want to get that one relatively close to 0. It doesn't matter if it's perfectly on 0. This turns a little bit, but you want to get it close to 0. But there's also one right here that goes 0, 1, 2, 3, 4, and then this is 5 again. Okay, that's got a 1/2 inch sweep. That's why it comes back to 5. You're going to want to get that on 0. Okay, focus whenever you're trying to set your thing, your needle here, and your depth checker. In my case, it was a 3-inch. You're going to want to try to set this one to 0. Okay, this one, if you're off just a little bit, it'll be fine, but you want to be able to read this one as 0. Okay, and now you have, once you get them all zeroed up, from the base here, and this is going to be exaggerated, but let's just say that this is the tip. From the base here to here is going to be 3.000. Sorry, I went to write inches like a carpenter, but 3 inches. 3 inches perfectly from the base here to here. Okay, to get that, like I said, to get this lined up, you're going to have to use this jam nut. Once you get this one lined up, tighten that jam nut down, and then you can fine tune this one by, there's a little screw you would loosen up and adjust the dial. Alright, so what you're going to do finally to check your pinion depth, okay, once again, this is my pinion gear, okay, and I'm probably going to be able to draw half of this, but you'll get the idea. Okay, this is my carrier, okay, not the cap, the carrier. Okay, you're going to want to take and put that metal bar however you can get it. And this isn't going to be exact, just pretend like it's coming towards you, and you're going to hold it as flush as you can right here. Alright, and then you got your dial indicator on it, and you got your needle or your stem going all the way down. I know those didn't line up, but just pretend with me. Okay, take this one first. Okay, and then this one second. Alright, as you push this down, you're applying force downwards to get it to sit flush here, and you want to hold this as flush as possible. Okay, you are going to get a reading, and let's say the thing goes to here, it's pointing at the 2, and let's just say it points at the 290. Okay, 2, and it's pointing at the 90. Okay, so that means that from 3 inches, 3 inches would be somewhere over in here, like somewhere down here, we are 290 thousandths up from 3 inches from here. So you get what I mean? Like if we took this pinion out, 3 inches, and this is the center line, would be somewhere to here. Okay, we got 290 thousandths. Actually, if it's pointing at the 2, close to the 2, I'd say it's 190 thousandths. That's probably confusing as crap. If it was pointing somewhere right here, it'd be closer to 3, it'd be 290. But now that I'm looking at it, let's just say it points at the 10, 210. 210 thousandths. So that means that this distance from here and our known distance of 3 is 210 thousandths. Okay. Alright. I know I confused it up here a little bit, but let's just say it's pointing at the 10 and the 2. Because if it was pointing at the 2 and it was pointing at the 90, I would assume that it hadn't gone the full way around to 0. And those two numbers should be flip-flopped. But you get what I mean. If it's past the 2 and it's between the 2 and the 3, like you read a clock, and it's pointing at the 10, it's 210. Okay. So this distance is 210 thousandths. So from our bearing center line, we need to take 3 inches, because that's our known depth, and subtract 210 thousandths. Point. So 0 from 0 is 0, and then we borrow, and then it's a 2 and a 9, because we borrowed 10 from that, and then a 9. These two are going away. 9 minus 1 would be 8. 9 minus 2 would be 7. 2 drops down. We are at a total distance from here to here, which is our center line, 2 inches 700. Wait, I did that wrong. This should be a 9. 2 inches 790 thousandths. Sorry about that. This should be a 10. I looked at that and I was like, what? I'm sorry. As you can tell, this is semi-rehearsed. I know what I'm talking about and I'm trying to explain it, but this distance is 2 inches 790 thousandths. So, we wanted a bearing center line, ideally, of 2 inches 825. We got 2 inches 790. So what we need to do, and this is what I screwed up in the videos, and this is why you should always, double check yourself, and I did that by reattaching everything, not just assuming I knew what I was talking about when I didn't. If we want to increase this number right here, we want to increase this distance. We can't change this distance, but we take shims away from here to make this number go up. So with 2 inches 790, and we want to get to 2,825, that means a difference of 35 thousandths of shims. I would try to, if I could, take away 35 thousandths of shims to get myself to this 2,825. Okay, is everybody following? 2,825. Alright, now if this number was greater, let's say I had 2,890, just throwing a number out, okay, that would mean that this distance is too great. From here to here is too big, and we need to bring it in some. So I would have to add, which this would be a lot, what would it be, 65 thousandths. I would have to add 65 thousandths more shims behind that pinion. Okay, and that would make this number smaller. You got that? Okay, now let's deal in absolutes and reality. My instructions on my ring and pinion said that it needed to be installed plus or minus 0.002 thousandths. I need to add or take away shims. What I got it to was, I believe it was plus 0.005 thousandths. Okay. If I could have, I had a 15,000 shim underneath my pinion. I should have, if I had one, taken it apart one more time and tried to get like an 8 or a 13, or excuse me, a 10 or a 13 or an 8,000 shim to put behind my pinion to bring me within this range. I did not. I don't know who does. I've never seen a 10,000 shim. Not that I've done a lot of them. I've only done like 3. But I haven't seen a shim below 15,000. So I settled for plus 5,000. Which, if you think about it, even though the instructions said to put it on here, alright, you have every Tom, Joe, Dick, Bobby, Billy sitting there putting their, just going off the gear pattern and what looks right. That provided an excellent pattern. Plus, I also think that with this tool, where am I going to go back in my, actually it's probably this one, Myriad of Drawings. Yeah, this one. When you are holding this, alright, because you're only going to use about 2 fingers to do it, this has a lot of, flex to it. You got to be really careful and precise with it. Okay? You don't want to do this or that, but I'm pretty sure that you could be off a couple thousandths one way or the other just by holding it there. So I would not stress if you cannot get your measurement perfect. You can get it as close as possible, and with this tool I had the best gear to pinion contact that I have ever had setting up a set of gears. The pattern looked the best. I don't care. Okay? It may not be perfect, but it's better than guessing. And it's 1/5 the cost of the hockey puck style. And with a hockey puck style, yes, they are better, but you have to own a different one for every axle you're going to do. Whereas this one should work with all of them. Okay? I hope that makes sense. I hope my drawings are good enough. I thought about bringing the actual tool out, but I thought I could explain it better by drawing it. So I'm going to put this as the first part of this video. If you would like to see me install gears in a 12-bolt Chevy with this tool, continue watching. If you just wanted an idea of how that tool actually works, because the instructions suck, unless you're already a machinist, you can cut it off right now. But either way, thank you, and have a good one. So it's an incredibly beautiful day outside, and I'm in the garage. The reason is, just in case you're watching this years from now, this is the great 2020 pandemic, and there hasn't been a whole lot of reason to get anything done in the garage because, well, there's nowhere really to go except just to ride around. Not saying that that's a bad thing. I've been doing a lot of that with a bike, but we the car's, I've been meaning to change. I wanted to redo the pinion gears in it. One of the reasons is I got 411s in it right now, and I think they're just a touch too steep. I still have great highway cruising, but taking off, first gear is way low and second gear is just a little bit too high. So I thought I would get that done. Plus, with the tractor being gone, I co-own the tractor. If you follow my channel, I'm gonna get some garage stuff knocked out and rebuild one of the boys' four-wheelers, or excuse me, dirt bikes. It had a bad head gasket, waiting on parts for it. So I ordered parts for this thing to change the rear end gears. This is a Summit Racing 373. I know that there's a breakover between 410 and 373, but this gear set is supposed to cross that breakover, like bridge it. It's supposed to be a thin set for a car. So we got that. We got our master install kit from Richmond Gear. I like these kits because honestly, I mean, if you're going to change the gears, it only takes a couple more minutes and maybe another $100 to change the bearings. Might as well change all the bearings too. I like this kit better than the kit I had last time because it seems like it has some thicker shims. If you've ever installed your carrier with a bunch of thin shims, sometimes it can be really goofy trying to shove all them shims in. And I've also got the Proform, I believe it's Proform, I don't know, the instructions are pretty generic. A universal measuring kit. I know this is one of the cheaper ones. The high dollar ones are like $400. I've never actually used one, but it'd be nice to know that I actually have the gear set in the right spot than guessing at it. I've read over the instructions. I agree that from a layman's point of view they are very complicated, but I think I can simplify it out a little bit. I have some machining experience and I'll explain to you why it is the way it is and how it works and why I went with it. The big reason I went with it was because this will work in my Silverado. It should work in my Ram Charger and my Ram and basically anything I have or could get. Whereas the real expensive kits, if you buy the high dollar ones, the $400 and some odd dollar ones, they'll work within a certain range, like Ford 8.8 and Ford 9-inch all the way up to Dana 44. But to get the Dana 60 or 80 or 70, you have to spend extra money to get an upgraded kit. Plus, I might do a gear set maybe once a year, maybe. So a $400 setup that only works with specific axles just isn't going to work for me. But alright, let's get this thing up and get it torn apart. I am not going to bore you with those details about how I pull the wheels and brakes off because quite frankly they're kind of vehicle specific, and I might jump ahead. I'll probably jump ahead right to where I have the diff cover off and explain to you what I got going on. Okay? Out. Alright, quick tech tip. If you, let's say you forgot to mark your caps, or in my instance where I've seen these caps, they appeared to be on the wrong side because I have two punch marks here, and I know I fixed it now. I got two punch marks here, but I also thought I had two punch marks here, and this cap was on this side, and this cap was on this side, whatever have you. Figure out what's right. These are machined as one piece usually. So they run a long boring bar through and they machine the whole way across. So they're married for life. So what I did was, first off, with these angles, this side has to face in. But you run your finger along the inside. And if you feel the ridge real good, it's probably not the right cap. So what you got to do is flip-flop them. In which case this one's got a little bit of a hair of a ridge right there, but this one's spot on. So if this one came from this housing, it has to be that one. Know what I mean? Alright, back to it. Whenever you're getting ready to push your pinion bearing off, make sure that you do it in a bearing puller, pusher thing, device, whatever you call it. I got this one at Harbor Freight along with the press. I highly recommend a press. If you can't do this yourself, get a shop to do it. But since I have the press, it just makes sense for me to go ahead and do it. Alright. Oh.
Yeah.
Okay. What you're going to want to find on your pinion bearings is a number. This one's marked with CD, which stands for center distance, and it's 2.87, actually 2.825. This is the old gear set, and it is CD 2.795. That's 2 inches 795 thousandths is where this one is supposed to be positioned from the center distance, centerline distance of your ring gear. And we're going to go over how to measure that, but the first things first, you can go ahead and keep recording. We're going to take our old bearing, and we're going to make a setup bearing, because you're still going to have to start off, at least on a GM 12 bolt, with a guess as to how deep it should be. So we're going to take and grind the center of this out just so it slips over, so we don't have to press it on and off a bunch of times to make sure we get our distance right. Now if you're worried about the different bearings and one being maybe a little bigger or a little smaller than the other, don't be, because bearing manufacturers today, the tolerances are really tight on these. So you might have a little difference, like a 0.5 thousandths or so, but it won't be any more than that. So I really wouldn't worry myself about that. Now if I could find, oh, there it is. Which one, who's it? Or the what's it on the end? All we're gonna do, just try desperately to hook it up to our air hose. We're gonna clean out the inside of this a little bit. Trying to get it to the point where this used bearing will just slide right over, and it's not there yet. So you're just going to want to sneak up on it. But anyway, I won't bore you with those details. And then pick a few shims, stick under it, and put it back in the car. And I'll get back to this after I got my setup bearing on. Okay? Go. Put my glasses back on so I'm cool. We'll rejoin you later. After about 20 minutes of grinding. See, I can take it off, and with a little wiggle, put it back on. Alright? That's what you're going to use to mock up and measure your depth initially.
Table.
You good? You done?
Are we gonna, am I able to go in?
Let me check my clock.
If I'm able to go in,
10 more minutes.
Dun, dun, dun.
Why don't you take it for a lap around town? Instead of around the yard. Go around town.
You enjoy.
That's where I thought he was going to begin with.
Should I stop this now, or?
Yeah, I said cut. And I forgot to mention, but make sure you use your old crush sleeve too. And put that all installed back to your car, torque it, and we'll take a reading. Alright, first things first. It says in the directions to measure the bearing race. So I pulled the bearing race out. And with my micrometer, I get a reading of, looks like 3 inches, 62.5 thousandths. 3 inches because it's a 3-inch mic, but it's 62.5 because every one of those dashes is 25, and then whatever the number that lines up on the line. So we're right between 13 and 12, and I'm going to say 6.25 because 6.25 is a 16th, so it's basically 3 1/16 inch diameter bearing. This is the carrier bearing race, by the way. I highly recommend investing in a set of good micrometers, at least up to 3 inch. This one's adjustable. I can change the pin out, and I'm going to show you why. Because they're a little bit more exacting. Because if I measure it with my verniers, I get a measurement of 3 inches. Well, actually pretty close. 3 inches, 63 thousandths, which is well within the tolerance of me screwing up. But it's, I just like it better. I think you get a better measurement, especially when we're dealing with in the car with a set of mics. So we're going to take our bearing measurement. Three inches, 0.62 thousandths. Okay, and then it says to divide that in half. And divided, that would be 1 inch, 531 thousandths. Okay, because half of 3 is 1.5, half of 62 is 31. Add them together, and that's what you get. Now it says to measure from the surface. Well, I'll have to get out the directions to read that, but basically you're measuring from the bolt hole surface to the bottom of the housing where the bearing brace sits. So you're basically measuring where that bearing goes into, and we'll get to that right now. Alright, so I have my caps reinstalled, and I'm basically going to get the measurement they want without doing it the way you would think. And I'll explain what I'm doing in a minute. But basically we're going to measure from this to here. I'm going to try to do it the best I can with my verniers, because that's probably what most of you have. We'll see what we get here. This is going to be a difficult one to do. What we're going to do is we're going to go for a little bit of feel. I'm sorry for the noise of the fan, but it's just what it is. And we have 3 inches, and it looks like about 25 thousandths. 3 inches, 25 thousandths. Okay, I'm going to double that. Double check it. See if I can get the same measurement twice. It's really an awkward thing to do. And I got about 3 inches, 15 thousandths that time. So to me, that's a real awkward way to do it. The way I've seen other people do it online is they actually bolt the wetchahiggy onto here, and they move the feeler back and forth until they get the highest number, which you can do that too. But I think the most surefire way is going to be with one of these. This is called a snap gauge, and what it does is you twist the bottom and it pops out. So what I like to do is twist it up. This is how I use it. I'm going to put it in the hole, and maybe I twisted it too much. Hang on. And get it there. Now this thing's self-centering too. What you want to do is put it in a little bit of an angle, tighten it back up, and then pull, and it'll automatically find the widest spot, and when it comes loose, that's your perfect measurement from this point to this point. Yeah, it's not out even, but it doesn't have to be. So we're going to go back to my micrometer. Oh, sorry, my micrometer is from this point to this point, sorry. And check that measurement and see what we get. So I had 3 inches 25 and 3 inches 15 thousandths originally for the overall width. Now we're going from this side to this side. We're not going up and down. We're going from here to here. And I'll explain why we took that measurement when I go back over to the pen and pad. Alright, so we're back at our pen and paper. I'm going to take our mic. Take our measurement. And that is 3 inches. I can't tell if it's blurry or not in the camera. 3 inches 62 thousandths. So we're within a half thousandth, which is about what I want. It's about what I figure. So we're still at 3062. Now you see how much closer that is? Because with the Verniers, I got between 325 and 315. So we're still at 1.531. Now the difference is where they say to add or subtract some numbers. Now the reason that they're worried about that is, I'll tell you this, there's a couple different ways that you can machine a part to clamp something. One is you take a solid piece of metal and then you bore a hole in it, okay? Then you come in with what's called like a slitter wheel or a cutter and you cut this out, okay? And then what the material you remove from here is called your kerf cut, okay? And whenever you clamp this down, this material is going to be missing. So it's kind of it's a perfect circle, but it's not like whenever you close it, this distance here will be shorter than this distance from this side of the circle to that side. Or you can start with 2 pieces of material, clamp them together, and then bore your hole. And that's what we have here, where it gives us a perfect circle. Now there's one other instance that basically creates this, and that's where you clamp 2 pieces together with a shim in between and then bore your hole and then remove the shim. But it all depends on how much clamp and how much force you want on the load with your bearing. You don't want more than, I'd say in my experience, a half thousandth when it comes to a bearing. So we're looking for our center line, our center distance from the bottom of the bore to this is 1 inch 531 thousandths. So from that bore, the closest it comes to the pinion from the center line, it's 1 inch 531 thousandths. Alright, now on to more stuff. Alright, setting this thing up sucks. I'm not going to deny it, but once it's set up, it's not too bad. Now, one thing you have to remember is if you're 5 and 10 thousandths even off, it's not the end of the world, because you only got, like, my smallest shim's a 15 thousandths anyway. But anyway, the easiest way I found to set this thing up for 0, and you want to do it with the collet. Get it as close as you can with the collet. And the main reason is that little guy right there, that's your 100 thousandths counter. Okay? So I brought it over here to the vise. After wrestling with my hands, I brought it over to the vise. And if you play with it enough, loosen and tighten in this collar, you can get it right about spot on. Right about spot on 0. Okay? And then if you can't get it, like let's say you get within 5, go ahead and move your dial. You loosen up this guy here, and you can turn the whole dial. That's what I thought originally, but you want this counter to start at 0, which it does. It's actually 0.5 thousandths, or 0.5 inch, 500 thousandths, so keep that in mind. But I've got 3 inches of extension on. Okay, and what you're going to do, I'm going to put you down in here. So once you get that zeroed out and you figure out which one you need. Now remember, I got roughly a 30 thousand shim underneath this pinion right now with just the setup bearing. Torque down with the crush collar. Now, sorry if I get in the way of my own camera. I'm going to try my best not to, but it's tough to shoot and film at the same time. But basically, there we go. Basically what you're going to do is you're going to set this onto here, on this flat part onto the bearing cap mount, as close as you can get it. Okay, and then as you start to push in on it, you're going to watch this bottom dial. I can see it from the bottom. It'd be a lot easier out of the car, but anyways, it's going to go 100. Have to push it around. Oh. It's going to be at almost 200,000. So now I'm going to look to my thousandths whatcha-higgy, and it says 90. So we're 190 thousandths from the center line. Okay, pretty close to 190 the whole way around. Don't get too wrapped up in 5s and even single digits or anything like that. I mean, yes, in a perfect world it would be, but this is going to be the world of close enough. Because you got to remember, most people aren't even going to go this far. They're going to put some marking compound on it and call it done. Now if I can get back out. So we got our measurement. We're 3 inches below 190 thousandths. Or 190 thousandths minus 3 inches. So you take 3 inches and you subtract 190 from it. So if I open this up, it's already 5 o'clock. Sorry, cheating a little bit, but 3 minus 0.19. I could add the 0, but I'm not going to because of math. 2 inches 810. We want 2 inches 825. So to increase that number, what we would have to do is move it, let me think. To increase that number, we'd have to move it in closer. So that means we need to add another shim. Now I have a 30 thousandths in there. The smallest one I can add is a 15. Okay? But that should put us right on the money. I'm going to double check it. I know I recorded it. I'm going to double check on the end of the pinion before I push everything off that I need to come in, that I want 2,825. If I do want 2,825, then I'll just add this 15 and we'll be done. I'll press the new bearing on. Alright, well, you should always double check and try it out anyway. So at 15,000, so we're at 345. Plus I found out that the last time I actually forgot to put the crush collar in. So put the crush collar in this time, which of course changed things a little bit. But I got 210 thousandths difference. So if you take 3 inches minus 0.210 equals 279 thousandths. So we came way 2 inches 790 thousandths, which is the wrong direction. So what we're going to have to do is add, or actually take away, if we take away, let's take away that 30, so that's plus 0.03, give us 282, which is about as close as we can get. Alright, let's take that 30 out. Alright, last time I measured was 180 thousandths, which if you take 3 inches and subtract 0.18, you get 2 inches 820 thousandths. Our goal was 2 inches 825, and unfortunately I've only got a minimum 15,000 shims, so if we added another 15, that would put us at 2 inches 805 thousandths, and if I took all the shims out, it would bring us back to as low as it could go. I would be at 2 inches plus 53, 835 thousandths. So there's no way for me to regain that 5 thousandths. Honestly, I think that's really good. And overall, I'll finish this video up showing you the pattern, but overall I will say this about the tool. Is it easy to use? I'm gonna say it's not easy to use because you first have to understand the tool, which is what I hope that I described here. There's nothing physically clamping this anywhere, which I kind of wish it had. I wish you could, maybe if in the future, if I was to do a bunch of these, I'd drill a hole there and then use a cap bolt or something to actually bolt it down to hold it straight and flush, or make up a small bar where I could clamp it to, something along those lines. Like I said, this is an out-of-the-box thing. I can modify it all day to make it easier. But what was nice is, like I said, that 2 inches 820 thousandths. I know without a whole bunch of guessing and popping that stupid carrier in and out and in and out and painting the teeth and checking the pattern all over and over and over and over and over and over and over, only to finally get it in where you want it and then have to tear the whole stupid thing back apart again to put everything back together correctly, because you got to take that setup bearing out. I still do have to take it apart. I still have to press on my new pinion bearings. I still have to knock the new one in, you know what I mean? Yeah, I think this is carrier, pinion, probably the outer pinion, as in the one that closest to the drive shaft. But, you know, at least when I press this bearing on, I know almost without a doubt that I'm where I need to be, or as close to where I should be as you can get. You know what I mean? Nothing's ever perfect. Even leaving the factory, it wasn't perfect, but at least with this, I can get it really close to perfect. And like I said, I mean, of course, assuming I check my pattern, it's all good. If I check my pattern, it's all bad, I'm gonna come back, do another demo, and tell you this tool's a piece of crap. But I still gotta get my ring gear on, mounted, bearings pushed on. It's 7 o'clock now. I don't know how much further I'm gonna push tonight, but we'll see. All right, out. I bought this Richmond Gear installation kit from Summit Racing, and I gotta give a mad props out to them, because not only are their shims nice, but they also, the bigger ones, actually index off each other. So whenever you're trying to put them in with your carrier, they actually stay in place. And when you're trying to pull them out, like, there's something to actually hold them in packs, because the old set I had, which is over there, doesn't have any. Whenever I pull the carrier out, sometimes these would just fall to the ground and get scattered, which sucks, because then you got to figure out how much you had, not only how much you had on each side, how much you had to move, but how much you had overall, and that really sucks. But we're getting our backlash set up. We want to be, I think it's 5 to 9, 5 to 10, something like that. Anyway, I'm at like 20,000, so I'm not even close. So I'm gonna keep shimming it in. So they say that you're making the same mistake. Don't ever make the same mistake twice. Well, I'll let you know I didn't, but I think I got that a little too oily to get a good read. So we're going to try it now with those 3 teeth. Now keep in mind there's a lot of teeth with oil on them, or excuse me, compound. Well, I got full tooth contact across the face. You can see it, like that goes from here to here. So, especially on this tooth that wasn't really, I don't know if you can see that. It wasn't really contacted. Actually, let me just take you off the stand so that I can tell what you're seeing. So, if you look at this tooth, it's from here the whole way to there. So I got full tooth contact. It's scraped almost completely to the bottom. It didn't take it all off clean to the bottom, but it's scraped almost completely to the bottom. And as far as the bottom side, it's a little to the outside, but that's what I think you can be expected. Like I said, I don't have to work on mixing that stuff up, but I'd say it's a pretty good contact patch myself. So, in conclusion, the tool itself was actually pretty difficult to use, but it did its job. It did make this a quicker, easier, I'm more sure of where I'm at kind of a deal. But it's not an expert professional tool, it's not a specialized tool, it never will be. And for those reasons, I'm going to say that if I was a professional shop, I would definitely buy something better if I was making money off it. But for the hobbyist, somebody maybe does 1 gear set a year, if that, can't beat it. All right, good.